Hello everyone and welcome to my YouTube channel. Today we are going to look out for eigenvalues and eigenvectors question from the IIT JAM 2017 question paper, and we have two questions which were asked. So one is question number 38. It's an MSQ question, multiple select question, which means it has more than one correct options, and we got to select each one of them to get the maximum marks. And the next one was question number 58 from N80 numerical answer types, carrying 2 marks. So let's get started with both of them. This is question number 38. Let M be an n by n matrix with real entries such that M cube is identity. Suppose that MV is not equal to V for any non-zero vector V, then which of the following statements is or are true? And we have got 4 statements. M has real eigenvalues, M plus M inverse has real eigenvalues, N is divisible by 2, and N is divisible by 3. Since it is an MSQ, multiple select question, we need to select all the correct options, which could be more than one. We'll be starting with the condition given to us as n cube equals I. So suppose say lambda happens to be an eigenvalue of this particular matrix M, which has order n by n and real entries, then we can say that lambda cube is equal to 1, and this gives us that lambda cube minus 1 is equal to 0. For those who already know that lambda cube equal to 1, the solutions are going to be the cube roots of unity, which are given by 1, omega and omega square. Now we'll be just quickly solving this and seeing what are these cube roots of unity. Solving lambda cube minus 1 equal to 0 gives us that on factorization lambda minus 1 lambda square plus lambda plus 1 is equal to 0. So therefore we have one solution as 1, and for the quadratic factor we are going to use the formula method. So we have lambda is equal to negative 1 plus minus 1 square minus 4 into 1 over 2 times 1. So this gives us negative 1 plus minus square root of 3i over 2. And as you can see, these roots are complex conjugates. So we can say that lambda 1 is 1, lambda 2 is equal to negative 1 plus square root of 3i over 2, and lambda 3 is equal to negative 1 minus square root of 3i over 2. So those who are familiar with complex number, this is the complex number e raised to 2 pi I over 3, and this is equal to e raised to 4 pi I over 3. So thus we have got 3 solutions to this. Now before coming to the conclusion that these 3 are the eigenvalues, please note that I will be using the word that these 3 are the possible eigenvalues, and that I am saying because of this expression. So it is said that MV is not equal to V for any non-zero vector. Now if you can recall that for eigenvectors and eigenvalues, we have the equation to be AV should be equal to lambda V. Now in this case, we have said that MV is not equal to V, which means that MV is not equal to 1 times V for any V which is a non-zero vector. Thus it is not difficult to understand that lambda 1 equal to 1 is not an eigenvalue of the given matrix M. So thus we have 2 eigenvalues, one of which is this, and the second one is the complex conjugate of that number. So earlier I was talking about the cube roots of unity. So thus 1 omega, you can say that omega is this number and omega square is this number. So these are the 3 complex cube root of unity. Now once we are done with that, we can come to the first part and conclude that option A is wrong, since it states that M has real eigenvalues, and here we have got 2 eigenvalues which could be repeated multiple number of times since we don't know what is N, and it has complex eigenvalues. Now let's move on to the second option, B, M plus M inverse. Now We'll be starting again with the basic part. So if lambda is the eigenvalue for M, this will imply that lambda inverse, which is equal to 1 over lambda, is eigenvalue for M inverse. Now we had that lambda cube is equal to 1, and so from here just factoring out a lambda, we get lambda square times lambda is equal to 1, and since lambda is non-zero, we can say that lambda square is equal to 1 over lambda, or alternatively 1 over lambda is equal to lambda square. If we talk about the matrix M plus M inverse, then its eigenvalues are lambda plus 1 over lambda, and for 1 over lambda we can replace it by lambda square. In option B, we got to check that M plus M inverse has real eigenvalues. So we'll be talking about the eigenvalues for this matrix. Now since we know that there are only two options, one is omega, which was -1 plus square root of 3i over 2, and the other one was -1 minus root 3i over 2. Now this expression is nothing but e raised to 2 pi over 3, and this is e raised to 4 pi over 3, which follows from the Euler's formula. It states that e raised to I theta is equal to cos theta plus I sin theta, and you can verify the above two equations. Now if this is lambda 1 and this is lambda 2, then we got to check what is lambda 1 plus lambda 1 square. So that's going to be e raised to 2 pi I by 3 plus e raised to, so when I square this expression, the powers will be multiplied by 2, so that becomes e raised to 4i by 3. So that is nothing but this next root, which is the complex conjugate. So we are supposed to add lambda 1 and lambda 2, which are complex conjugate pairs of each other. If we add the conjugate pairs, then the imaginary part is eliminated, and this is going to reduce to a real number. And likewise, if we talk about the sum for lambda 2 and lambda 2 square, so that's going to be e raised to 4 pi I by 3, and likewise here it will be e raised to 8 pi I by 3, and further this can be written as e raised to 4 pi I by 3 plus e raised to 2 pi I by 3, reducing by 2 pi, and again this is same as above, it is going to be a real number. Thus the statement that M plus M inverse has real eigenvalues is going to be true. Now for C and D, we are interested in knowing that whether n is divisible by 2 or by 3. So note that the matrix M has only two eigenvalues, so it could be repeated a number of times. Now in case say lambda 1 has algebraic multiplicity k, then lambda 2 being the complex conjugate will also have the algebraic multiplicity as k. And if we take the sum of the eigenvalues, then this is going to be 2k, which is a number divisible by 2, and hence option C is going to be the correct answer. And for n being divisible by 3, we can likewise conclude that this is incorrect, because not necessarily all the time the number 2k will be divisible by 3. So that's problem 38. It has two correct answers. One is option B and one is option C. Now let's move on to the next problem. So that's question 58 for you, a numerical answer type problem. And we are given a 4x4 matrix with some numerical entries, and we are told that alpha, beta, gamma and delta are the eigenvalues, and we wish to find out the value for alpha square plus beta square plus gamma square plus delta square. Now we'll be doing this in a very straightforward manner. We'll be finding out all the eigenvalues for this matrix, and then once we have the eigenvalues, we are just going to substitute in the required expression and get it. So as we know that the eigenvalues are given by the determinant of the matrix, so call this matrix as A. So the determinant of the matrix A minus lambda equals 0. Now first we'll get on to A minus lambda. So that's negative lambda in the first row. Then we have 1, negative lambda, 0, negative 2 in the second row. 0, 1, negative lambda, 1. And 0, 0, 1, 2 minus lambda. So this is equal to 0. I will be evaluating the determinant using the first row. So in the first row we have negative lambda and the corresponding minor is this. So this must be equal to 0. Now for the 3 by 3 matrix which we have got, we will be using the first row to evaluate the determinant. So again we have negative lambda on the outside and then we have negative lambda and the determinant of the corresponding minor which is this. So it is going to be negative lambda, 2 minus lambda minus 1, and then we have the number negative 2 here. So this is going to be negative 2 and the corresponding minor which is this. So we have 2 times 1. This is equal to 0. Now simplifying, we have negative lambda and here we are going to get negative lambda, negative 2 lambda plus lambda square minus 1 minus 2 is equal to 0. So we have negative lambda and multiplying over here we get 2 lambda square minus lambda cube plus lambda minus 2 is equal to 0. So since the negative lambda is already factored out, we are going to keep it out. Now inside the bracket in the first 2 terms I can take lambda square common and here I don't have any common factor, so 1 could be a common factor. So we have negative lambda times lambda square 2 minus lambda and we need a 2 minus lambda, so I will factor out negative 1. So we have got 2 minus lambda here as well is equal to 0. And thus it is not difficult to see that this is negative lambda square minus 1 times 2 minus lambda is equal to 0, which is nothing but lambda minus 1, lambda plus 1 and lambda minus 2 equals to 0. Thus we have got the 4 eigenvalues as lambda is 0, lambda as 1, lambda as negative 1 and lambda as 2. Now as per the question, we are going to call this as say alpha, beta, gamma and delta, and we are looking out for the value for alpha square plus beta square plus gamma square plus delta square. So that's going to be 0 square plus 1 square plus negative 1 square plus 2 square. So this is 1 plus 1 2 plus 4, that is 6. So thus for question number 58, 6 is the correct answer, and once you get this you fetch 2 marks. So that's all in this video. I hope you follow the concepts which I am trying to explain. If you do understand the things, please like the video and also share it with your friends. And if you have not yet subscribed to my channel, then do subscribe the channel and also hit the bell notification to keep updated on the upcoming videos. Thank you so much for watching and happy learning.